In this video, we are going to look at using some formulas to do our arithmetic and geometric series. Remember, series means that we are adding them together, adding the terms of a sequence together. We can use formulas specific for arithmetic and geometric. These only work if it's arithmetic or geometric, and they allow us to add up those terms. So our first one is our arithmetic. The formula, the notation, first of all, that big capital S with the sub n, S with a subscript of n, that's going to be the summation of the first n terms. So S sub 10 would be adding up 10 terms. And this is the formula. I'm going to take n times, and then notice what we have in the second half is the average of the first and the last term. So we're going to add the first term and the last term and divide by 2. Now, if you watched that first video, you saw us adding up the Gaussian way, 1 to 100, the famous story of the teacher, Gauss's teacher asked him to add up from 1 to 100 just to keep him busy. And he did it really quick by doing 2 lists and ordering them up and getting to where we needed to be. And that gave him the 50-50. If I use the formula, it's going to give me the same thing. So S sub 100 of this arithmetic sequence, arithmetic series, because it's got the addition signs there, where n would be 100, my first term would be 1, my last term would be 100. So notice what I get with my formula is the same as what he got when he did it using his 2 lists. So the formula does work for very much the exact reason that it worked for Gauss. We're not going to prove it, but we are going to use it. Okay, example 1. We are going to find 2 plus 4 plus 6 plus 8 plus ... and we're going to go to S sub 10. So it's going to be n times, I know a sub 1, I don't know a sub n yet. So I need to continue until I get to that 10th term. So I can either keep going, 2, 4, 6, 8, 10, 12, 14, 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my 10th term, or I could have written an equation if I wanted to, using my mx plus b. So I get 10 times 22 over 2, which is 10 times 11, so 110. So if I add 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20, I will get 110. Now we can write this a different way. We can write it using that summation notation. So notice this one, we know it's arithmetic. We have to be able to identify that. So we know, because I told you it's arithmetic by titling this part arithmetic, but we also know because this is linear. If that is linear, then the function is arithmetic, which tells me that I can use my formula. Okay? Now, I'm going to go from the first term to the 12th term. First term to the 12th term. So my n is going to be 12. My a sub 1, I'm going to plug in 1 to my explicit formula. So I get 6 minus 4, which is 2. And my a sub 12, which is my last term, I'm going to plug in 12. So I get 60, 72 minus 4, which is going to be 68. So 2 plus 68 over 2. And I got a little messy here, didn't I? Let me clean it up a little bit. Let's move this over here. There we go. And then that's going to give me 12. Sometimes my pen doesn't want to work. 12 times 70 over 2. And I'm going to go to my calculator for that and get 420. and that is our arithmetic sequence, or sorry, arithmetic series, So let's do geometric. We're going to do the same thing, but these will be the geometric ones. It's a different formula. And it doesn't apply to that 1 to 100 thing because that one was arithmetic. So this one is geometric. This one is specific to geometric. So our formula, big capital S sub n for the sum of the first n terms. And we're going to do a sub 1 times 1 minus r to the n over 1 minus r. So n is your number of terms, a sub 1 is your first term, and r is your common ratio. Pause if you need to get this written down. Let's take a look at our first example. Okay, so here we have geometric and our first term. So what we need to know for our formula, we need to know n, we need to know a sub 1, and we need to know r. We need to know those three things. We need n, we need a sub 1, and we need r. So it tells me to find s sub 20. So n is 20. A sub 1 is easy, that's 81. And my r, we know it's geometric. So I'm going to do 81 times what is 27. If you're not sure, do 27 divided by 81, which is going to give you 0.333, but we're not going to write it like that. We're going to write it as 1/3. So my ratio is 1/3. I am multiplying by 1/3. Be careful there, don't say 3. Because 3 would be multiplying by 3. My numbers would be getting bigger. My numbers aren't getting bigger, my numbers are getting smaller. Okay? Now, my formula. I'm doing S sub 20. And my formula, trying to pinch it so I can see my formula. Shouldn't have made my formula quite so big. There we go. My formula is a sub 1, which is 81, times 1 minus r, 1/3, to the n, 20, over 1 minus r. That looks super messy, right? You know what we're going to do? We're totally going to our online calculator. So we're going to open up our online calculator. And we are going to punch that in exactly as we see it. I'm not going to simplify it at all. I'm going to go fraction, 81 parenthesis. My computer does not want to work. Parenthesis 1 minus parenthesis fraction 1/3. Whoops, I don't need a parenthesis there. Parenthesis, going to close it, to the 20 over 1 minus fraction 1/3. So see what I did there? See how it looks exactly the same? That's the joy of this calculator, 121.5. So this one equals 121.5. So use that online calculator, especially for this one, especially when you have fractions. Yuck, that would be super yucky without it. Again, I don't even simplify it any. I just type it in exactly as I see it, Okay, let's do example 4. So in example 4, again, I'm giving it to you in this summation notation, but I know that it is geometric because this is exponential. That's your explicit formula, and it's exponential. So I know that this one is geometric. So I'm going to use my S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Let me check and make sure I got that right, because I don't always have this one memorized correctly. 1 minus r over n. Sorry, I wrote it a little different. It's the same, but I wrote it different, so I don't want to confuse you. Let's try that again. You see what I mean by that's the same, right? Okay, so my a sub 1, I've got to plug in. So it's going to be 32 times negative 1/2. I am too messy. We're going to move this for now. To the 1 minus 1, well, that's 0. And anything to the 0 is 1, so that's going to be 32 times 1, which is 32. I knew that from looking at it because of right there. My r is negative 1/2, because that's what my equation is coming from, and my n is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm getting that number from right here. Okay, now let's do our formula. S sub 11 is going to be a sub 1. It's not a coincidence that it ends up being that number. That's what it's going to be. A sub 1 times 1 minus r to the n over, I totally didn't mean to give us one with both with fractions, but that's okay. Why am I so messy today? There we go. And again, I'm totally going to my online calculator, and we're just going to plug it straight in. So fraction bar, 32, parenthesis, 1 minus, parenthesis, negative, fraction, 1/2, parenthesis, to the 11th over 1 minus, parenthesis, negative, fraction, 1/2. Close your parenthesis. Whoops. So 21.34375. 21.34375. Okay, that was a lot. We're going to have one try on your own. Pause here and make sure you have it all before we go forward. One more example. You're going to make sure to try this example on your own and turn it in on time in order for you to get your full credit, okay? So here is our example 5. We're looking for this summation. So you're going to try this one on your own, but I'm going to give you some hints. Start by just working with the sequence. From the sequence, determine your ratio. And then for your n, so from the sequence, you're going to determine your ratio. It's going to be negative. And then for your n, how are you going to figure out how many terms it takes to get to 2,916? That's going to give you your n. And then your a sub 1, you obviously know. So those will be the variables that you need there. So you're going to try this, then you're going to do pictures and submit. And again, it needs to have attempt here. It doesn't need to be right, but it needs to be attempted when you submit it for full credit.